Alright, good afternoon viewers. Once again, we have a very simple problem in moment of a force. Here we have a question that a uniform meter rule AB rests on two knife edges at both ends. Now a body of mass 40 kg is hung 1/4 of its total distance away from point A, while another body of mass 60 kg hangs 30 centimeters away from point B. Calculate, they say we should calculate the reactions at point A and B if the mass of the meter rule is 80 kg. Let's go together and solve this problem. Now, first and foremost, to solve this problem, let's take a look at the parameters. First and foremost, we are told that the meter rule is a uniform meter rule. And we know that a uniform meter rule have a length of 100 centimeters, which is equivalent to 1 meter. And they said, two knife edges, it is resting on two knife edges at point A and B. So let's see, here we have point A, this is point A, and I have my point B. Now remember, the meter rule is a uniform meter rule. So the mass of this meter rule lies at the center of mass. So at this point, the 50 centimeter mark, we have the mass concentrated at the middle. And since they said we should calculate the reaction force at point A and B, remember Newton's third law. This body meter rule is resting on the knife edge. The knife edge will exert an opposite reaction force upward. So we see that as R2, and at this point also there will be a reaction here upward. Let's say that is R1, and this is what they say we should calculate, R1 and R2. Now, since this is a force, the mass here will also be converted to force. Remember, they said the mass of the meter is 80 kg, so 80 times 10, and that will be equal to 800 Newton. That is the weight of the meter rule. Now, look at it, that a body of mass 40 kg on 1/4 of each total distance away from point A. The total distance we have here is 100. So we know that 1/4 times 100 is supposed to give us 25. So that will be 25 centimeters. It means that 25 centimeters away from point A, we have a body of mass. Let's say this is 25 centimeters. We have a body of mass, and that body of mass is said to be 40 kg. 40 kg. And 40 kg is the same thing as 400 Newton. Yet, let's take a look at it. That another body of mass, 60 kg, hangs 30 centimeters away from point B. This is point B. We have another body of mass on 30 centimeters away from point B, and that is 60 kg, which is equal to 600 Newton. So this is what we have now. Now let's have just a sketch of it. Here we have the knife edge. Here we have the knife edge. Here we have the middle, the weight of the meter rule, and we have it as 800 Newton. Here we have the body of mass, weight of what? 400 Newton, and the distance away from point B is 25 centimeters. While here we have another weight here, that is 600 Newton, and it has a distance of 30 centimeters away from point A. This is point A, and here we have point B. So this is what we are looking for, R1 and R2. That is what we are looking for, R1, and this is R2. Now let's resolve. I want us to understand that sum of forces acting upward should be equal to the sum of forces acting downward. So if sum of forces acting upward equal to forces acting downward. So we have it that R1 plus R2 will be equal to, I have 400 plus 800 plus 600, and this will be equal to 1800 Newton. So it means that my R1 plus R2 is equal to 1800 Newton. We'll keep this aside. Now we'll begin to resolve. Let's resolve to get the value of R1 and R2. Now let's take moment at point A. We are taking moment here, so let's assume this is the point where we take moment. Now, taking moment about point A, taking moment about point A, about point A. Now, what does it mean to take moment about point A? Taking moment about point A means that you taking moment about point A. Take a look at it. Now, what is moment? Moment of a force is the turning effect of a force and its perpendicular distance. Now, what is the perpendicular distance? This is acting towards the point of moment. 800 newtons also acting towards the point of moment. This also acting towards the point of moment. And this force also act towards the point of moment. Now, if you take a look at it, see that here we have the anti-clockwise moment. Here, these three all together form the clockwise moment. So we now take moment. Taking moment about point A, 400. So we have it here as 400 times the perpendicular distance. Here they are already to the 25 centimeters away from point A. So times 25 plus 800, which is the middle, the weight of the meter middle. 800 times the distance from here to here is 50. So I have 800 times 50 plus, and I yet have this one, 600 Newton, acting towards this point. 30 centimeters already gone. So from here down to this point will be 70. 100 minus 30, so I have 600 times 70. And this now will be equal to, remember, all this one now constitute the clockwise moment. Will be equal to the anti-clockwise moment is this one, taking moment from this point. So I have from this point down to this point is 100 arrow 2. So this will be equal to 100 arrow 2. So add this now. Let's evaluate this now. So 400 times 25 is supposed to give us there 400 times 25. That will give us 10,000. So I have 10,000 plus 800 times 50. That is supposed to give me 800 times 50. That is supposed to give me 40,000. 40,000 plus 700 times, is it? Sorry, 70 times 600. 70 times 600, that will give us 42,000. 42,000. All is equal to 100 arrow 2. We add them together. So 10,000 plus 40,000, that would be 50,000. 50,000 times plus 42,000, that would be 92,000. So 92,000 now will be equal to 100 arrow 2. Now with this now we have the value of our arrow 2. So our arrow 2 now will be equal to 92,000 divided by 100. We cancel, this cancel. So I have my arrow 2 to be equal to 920 Newton. But recall, let's recall that arrow 1 plus arrow 2 from the beginning, we said is equal to 1,800. Equal to 1,800 Newton. Therefore, my arrow 1 will be equal to 1,800 minus 1,800 minus arrow 2, which is 900.